How do Ramanujan numbers show up in math? Imagine discovering a number that holds a secret link to the way numbers can combine and relate. That's what Ramanujan numbers are all about. They are special numbers with surprising properties that pop up in many areas of math. The most famous Ramanujan number is 1729. It's called the Hardy-Ramanujan number because Srinivasa Ramanujan told G.H. Hardy that 1729 was the smallest number that could be written as the sum of two positive cubes into different ways. For example, 1729 equals 1 cubed plus 12 cubed, and it also equals 9 cubed plus 10 cubed. This makes 1729 a unique number called a taxicab number. It's like a puzzle piece that fits into many number patterns. This property of being expressible as sums of cubes in multiple ways makes 1729 stand out. It shows how numbers can hide interesting secrets that aren't obvious at first glance. Besides this, 1729 is a composite number, meaning it's made from multiplying smaller numbers. It's the product of three prime numbers, 7, 13, and 19. This makes it important in number theory, which is the study of how numbers work. Another fascinating fact about 1729 is that it is a Carmichael number. This means it acts like a prime number in certain mathematical tests used to check if a number is prime. This property makes 1729 important in cryptography, the science of secure communication. It's also a Harshad number because it can be divided evenly by the sum of its digits, which adds to its list of curiosities. Ramanujan numbers aren't just about sums of cubes. They also appear in geometric shapes called figurate numbers. For example, 1729 is connected to centered cubes and dodecagonal numbers, which are shapes made of dots arranged in specific patterns. These connections show how numbers relate to shapes and space. Ramanujan's work goes even further into series and identities. He discovered infinite series that sum to surprising results, like the Ramanujan summation, which assigns finite values to infinite series that normally don't have a sum. His identities also relate to partition theory, which looks at ways to break down numbers into parts. These discoveries help mathematicians understand the deep structure of numbers. In the world of computers, 1729 plays a role too. It's connected to the Fourier transform, a tool used in algorithms for multiplying large numbers quickly. This shows how these special numbers influence real-world technology and calculations. In short, Ramanujan numbers appear in many parts of math, from simple sums to complex series and shapes. They reveal hidden patterns and relationships that make the study of numbers exciting and full of surprises. They reminded us that even ordinary numbers can have extraordinary stories behind them.